Hey guys. Welcome to Burning Science channel. Today, we are talking about launch vehicle of Indian Space Research Organization. Number 1. SLV. The Satellite Launch Vehicle, SLV-3, was a 4-stage solid propellant light launcher. The project was headed by APJ Abdul Kalam. SLV was intended to reach a height of 400 kilometers and carry a payload of 40 kilograms. Its first launch took place in 1979 with 2 more in each subsequent year, and the final launch in 1983. All 4 SLV launches occurred from the SLV launch pad at the Sriharikota high altitude range. Only 2 of its 4 test flights were successful. Number 2. ASLV. The Augmented Satellite Launch Vehicle, ASLV, was a 5-stage solid propellant rocket with the capability of placing a 150 kg satellite into low Earth orbit. This project was started by the ISRO during the early 1980s to develop technologies needed for a payload to be placed into a geostationary orbit. Its design was based on satellite launch vehicle. The first launch test was held in 1987. And after that 3 others followed in 1988, 1992 and 1994, out of which only 2 were successful before it was decommissioned. The payloads of ASLV were stretched Rohini satellites. Number 3. PSLV. The Polar Satellite Launch Vehicle, PSLV, is an expendable launch system developed and operated by the Indian Space Research Organization. It is a medium-lift launch vehicle. It was developed to allow India to launch its Indian remote sensing satellites into sun-synchronous orbits. PSLV can also launch small-sized satellites into geostationary transfer orbit. Some notable payloads launched by PSLV include India's first lunar probe, India's first interplanetary mission which is Mars Orbiter mission, and India's first space observatory. PSLV has gained credence as a small satellite launcher due to its numerous multi-satellite deployment campaigns, with auxiliary payloads usually ride-sharing along an Indian primary payload. Most notable among these was the launch of PSLV C-37 on the 15th of February 2017, successfully deploying 104 satellites in sun-synchronous orbit, tripling the previous record held by Russia for most number of satellites sent to space on a single launch. The PSLV has 4 stages using solid and liquid propulsion systems alternately. The first stage, one of the largest solid rocket boosters in the world, carries 138 tons of hydroxyl-terminated polybutadiene-bound propellant and develops a maximum thrust of about 4,800 kilonewtons. First stage thrust is augmented by 6 strap-on solid boosters. 4 boosters are ground-lit, and the remaining 2 ignite 25 seconds after launch. The solid boosters carry 12 tons propellant and produce 510 kilonewtons and 719 kilonewtons thrust respectively. The second stage employs the Vikas engine and carries 41.5 ton of liquid propellant of unsymmetrical dimethylhydrazine, UDMH, as a fuel and nitrogen tetroxide as oxidizer. It generates a maximum thrust of 800 kilonewtons. The third stage uses 7 tons of hydroxyl-terminated polybutadiene-based solid propellant and produces a maximum thrust of 240 kilonewtons. The fourth stage is powered by twin engines, burning monomethylhydrazine, MMH, and mixed oxides of nitrogen. Each engine generates 7.4 kilonewtons of thrust. The variant of PSLV are PSLV-G, PSLV-CA, and PSLV-XL. Number 4. GSLV. The Geosynchronous Satellite Launch Vehicle, GSLV, is an expendable launch system developed to enable India to launch its INSAT-type satellites into geostationary orbit. It is ISRO's second heaviest satellite launch vehicle and is capable of putting a total payload of up to 5 tons to low Earth orbit. The vehicle is built by India, originally with a cryogenic engine, purchased from Russia, while the ISRO developed its own cryogenic engine. The 49 meters tall GSLV with a liftoff mass of 415 metric tons, is a 3-stage vehicle with solid, liquid and cryogenic stages respectively. The payload fairing, which is 7.8 meters long and 3.4 meters in diameter, protects the vehicle electronics and the spacecraft during its ascent through the atmosphere. It is discarded when the vehicle reaches an altitude of about 115 kilometers. GSLV employs S-band telemetry and C-band transponders for enabling vehicle performance monitoring, tracking, range safety, flight safety, and preliminary orbit determination. The GSLV can place 5,000 kilograms into an easterly low Earth orbit or 2,500 kilograms into geostationary transfer orbit. The first stage contained 125 metric tons of solid propellant and had a burn time of 100 seconds. Second stage is powered by the Vickers engine. It has a diameter of 2.8 meters. The third stage is propelled by either the Russian KVD-1 or the Indian CE 7.5 cryogenic rocket engine. It uses liquid hydrogen and liquid oxygen. The Indian cryogenic engine was built at the Liquid Propulsion Systems Center. The engine has a default thrust of 75 kilonewtons, but is capable of maximum thrust of 93.1 kilonewtons. The variant of GSLV are GSLV Mark 1 and GSLV Mark 2. Number 4. GSLV Mark 3. The Geosynchronous Satellite Launch Vehicle Mark 3, also referred to as the Launch Vehicle Mark 3, is a 3-stage medium-lift launch vehicle developed by the Indian Space Research Organization. It is designed to launch satellites into geostationary orbit and is intended as a launch vehicle for future Indian crewed space missions. The GSLV-3 has a higher payload capacity than the similarly named GSLV. After several delays, ISRO successfully conducted the first orbital test launch of GSLV Mark 3 on the 5th of June 2017 from the Satish Dhawan Space Center. The first stage of GSLV Mark 3 consists of two S-200 solid motors, also known as large solid boosters, attached to the core stage. Each booster carries 207 metric tons of propellant. The S-200 booster uses an HTPB-based propellant. It is the largest solid fuel booster after the Space Shuttle SRBs and Ariane 5 SRBs. These boosters burn for 130 seconds and produce an average thrust of 3,578.2 kilonewtons and a peak thrust of 5,150 kilonewtons each. The second stage, designated as L110, contains 110 metric tons of unsymmetrical dimethylhydrazine, UDMH, and nitrogen tetroxide. It is powered by two Vickers 2 engines, each generating 766 kilonewtons thrust, giving a total thrust of 1,532 kilonewtons. The L110 is the first Indian clustered liquid-fueled engine. The Vickers engines uses regenerative cooling, providing improved weight and specific impulse compared to earlier Indian rockets. The L110 core stage ignites 114 seconds after liftoff and burns for 203 seconds. The cryogenic upper stage, designated as C-25, contains 28 metric tons of propellant of liquid hydrogen and liquid oxygen. It is powered by the CE-20 engine and producing 200 kilonewtons of thrust. CE-20 is the first cryogenic engine developed by India, which uses a gas generator. The first orbital flight of the GSLV Mark 3 occurred on the 5th of June 2017, lifting off from the second launch pad at 11:58 UTC. The vehicle carried the GSAT-19 communications satellite, making it the heaviest Indian rocket and payload ever launched. The satellite was successfully placed into a geostationary transfer orbit at 170 kilometers. The flight also tested upgrades to the design from data acquired during the suborbital test flight. Thanks for watching the videos. Please subscribe the channel and press the bell icon for the latest update.